we're waiting for that to come up. So on our assignment sheet, last class we took our test. Those of you that were absent, I'll get you started in just a moment. And then you did worksheet number 1 for homework. That's what I'm checking today. So you can see this is definitely a longer unit than our last unit. It's still going to be a review of what you learned last year in pre-algebra, or algebra in part 1, but you can see it's longer. So this is our solving equations and solving inequalities. So our first unit we were doing order of operations, which simplified. Now we're going to get x by itself and solve for that. So today we're starting off with our basic solving equations and inequalities. You have worksheet number 3 for homework tonight. And then notice, again, we're back to our mini quizzes. So next class we'll have a mini quiz over that, and then we'll have some more with equations and inequalities. There is on day 3 just more practice if we don't have mini quiz on that day. But otherwise, we have mini quizzes each of the days. So we're looking at our test being, this is a black day, so on October 10th. So it'll take a couple weeks to get there. Okay. Any questions with this? So just like last unit, on the day of the test, we will turn in all these papers in order. So make sure that you're keeping your papers together, keep them in order. The numbers will help you out. Anytime you want to hole punch, I do have this hole punch over here. You're welcome to use it if you prefer hole punch papers. If you just prefer to have more, that's fine. So you just put it in. Alright, so let's go ahead then get out your homework. I'll come around and check that. Let me get my absent people started on their test, and then I'll come check homework. Let's see. What we're doing, we are solving equations and inequalities. Just a reminder, phone should be off and away, earbuds out, and ready to go for today. Hoods off so I don't get in trouble if security comes by and sees you guys with hoods on. Then I get in trouble and I don't want to get in trouble. Thank you. Okay, so solving equations and inequalities. So our last unit, we did something like this. Where we had 2x plus 3xy minus 4x plus 7. And we would simplify. We could combine our 2x with negative 4x. But we couldn't combine it with anything else because it had the same letter and the same exponent. So that was one of the big things we did. One of the other big things we did was order of operations, and that was our GEMDAS or our PEMDAS. Right, so first we dealt with any grouping, then exponents, then left to right we did multiplication, division, left to right addition, subtraction. So let's suppose we had something like this. Nice number for us. Alright, so we did any grouping first. So to simplify this, we could actually go ahead and multiply this out. Kind of think of it as 3 or 4 different chunks here. But we had to simplify underneath our radical first. We could go ahead and do our exponents while we're at it. Again, we just have to simplify our radical. And we have plus 4 minus 3. And then we just went from left to right, multiplication, division, or addition, subtraction. So negative 12 plus 2 is negative 10. So this became negative 10. Negative 10 plus 4 gave us negative 6. Negative 6 minus 3 is negative 10. So that's what we did before. Today when we're solving equations or inequalities, we're actually kind of working backward with our GEMDAS. Okay, so let's suppose that we have 2x plus 4 equals 10. So here we would start off by dealing with any grouping and exponents, and then multiplication, division, then addition, subtraction. Well, when we solve, we have this equal sign. So we're actually going to get a number for x. We're going to find out what x could possibly be, what value makes this equation true. So when we multiply by 2 and add 4, we get 10. And so we're going to actually go backward. We start off by doing addition or subtraction. So I want to get my x alone. I want to get this guy all by itself. So we have to get rid of everything else around it. Well, I have to get rid of my 2, and I have to get rid of my plus 4. Which one do I do first? Well, we go backwards. We get rid of addition, subtraction first. So I would want to get rid of my plus 4. If I am adding 4, what's the opposite of adding 4? subtracting 4. So I'm going to subtract 4. And you have to do it to both sides of our equation. Some of us like to go and draw that line there. Do it to both sides of our equation so that we keep that it's equal. If I take away 4 over here, but I don't take away 4 over here, you're no longer being equal. We have to be equal with our equation. So we get then 2x equals 10 minus 4 gives us 6. So now we have to get rid of this 2. This is 2 times x. What's the opposite of multiplying? Dividing. So we're going to divide by 2 again on both sides. 2 divided by 2 is just 1x. What is 6 divided by 2? 3. So now we know that x is 3. If I take 3 and put it back in, 2 times 3 is 6, plus 4 equals 10. So that's the number that makes this equation true. We didn't know what x was, we just solved and found out for it. So it's kind of like it's got a disguise on. We had to figure out, hey, it was actually 3. So this is what we're going to be doing today. We'll have equations and we'll have inequalities. Okay, so that's the big idea for today. Again, we're going backward with our geometry. Okay. I skipped our first page here. So this is just kind of an introductory thing to give us an idea of what we're doing here. Billy's mom has asked him to go to the store to buy milk for his breakfast in the morning. Here's the path that Billy has taken to the store. So here's our path. And then we're going to list the steps of how to get back home. So he went out the front door, then walked down 5 steps, then turned right, then walked 3 blocks east, then turned left, and 1 block north, and he entered the store. Okay, so this was his starting, and this was his ending. Okay, so now he needs to go back home. What's the first thing he's going to do to go back home? If the last thing he did was enter the store, what does he have to do to go back home? Exit the store. All right, so he has to exit the store. All right, gotta get out of the store in order to get back home. Okay, and right before that, he walked 1 block north. So again, he has to go opposite of that. If he goes north again, he's not going to go in the same direction. But what is that? 1 block south. Good. 1 block south. Probably should have said walking. That's all right. Okay. Hopefully, we're kind of getting the idea of things. What is he going to have to do next? Turn right. And you know what? It's probably helpful for those of us that aren't as familiar with it. North, south, east, and west. So the opposite of north we had was south. The opposite of east is west. Did you guys learn anything? Never eat sour watermelon or never eat soggy waffles. Did they ever teach you that? Does that sound familiar? I mean, soggy waffles aren't too bad as long as it's soggy because it's syrup. All right, so last thing we did was turn. We did is turn right. So what's going to be our next thing to counteract 3 blocks east? 3 blocks west. Do we agree with that? Go give me thumbs up if we agree 3 blocks west. Okay. So walk 3 blocks west. All right. Opposite of turn right. Okay, so walk down 5 steps. Let's do the opposite of that. Yeah, walk up 5 steps, right? Thank you. Okay, next time I'm going to call on you. Walk up 5 steps. So he was going down the stairs, he has to go back up the stairs now. And then Emma, what's our last one?
We're going to walk in the front door.
Good, walk in the front door. So that's our same idea when we're solving. So in order for Billy to get home, he couldn't have walked up the steps before he turned left. He needed to first get to the steps before he could go up them. So this is what we're doing when we're solving equations and inequalities. Again, we want to get that variable alone. A lot of times we use x, sometimes it's a different letter. But we want to get the variable alone. So we say our goal is to isolate the variable. So that means to get it alone. Only the variable. And so as we saw, in order to undo the operation, does anyone know what that means by operation? What do I mean when I say undo the operation? What are operations? Alessandra? Very good. We've got addition, subtraction, multiplication, division. So in order to undo it, we're going to have to do the opposite of it, or what we call the inverse. We use the inverse. All right, so before we continue on, again, let's think of our order of operations. What is the inverse of addition? Subtraction. Good. Notice how they're paired together. What's the inverse of multiplication? Division. Notice again that they're paired together. Okay. Now, here in our Algebra 1 class for right now, we aren't going to be dealing with solving when there's exponents, and probably not a whole lot with our grouping. That's something later down the road. Okay, so right now we're dealing with linear equations, which means our variable will have an exponent of 1. We don't have right now x squared or x cubed. That's something you learn later. Okay, so we use the inverse, and inverse, again, that's just the thing of the opposite. And we undo in the opposite order of Gemini. I'm going to put slashes there so we know that those are together. So we go in opposite order. So what we were doing before is, again, we were given what x was, and we would put that in and we would simplify, right? So we would first start off with 5 times 1 minus 3. And according to our order of operations, there's no grouping or exponent, so we would do our multiplication division. So we would have 5 times 1 is just 5, and then minus 3. Next is addition, subtraction, and that would give us an answer of 2. All right. But for solving, we don't know what x is. That's what we're trying to find out. Notice they tell us now, hey, it equals 2. They're telling us it equals 2. They give us how much it equals. Now we have to find how much x is. So before they gave us x, and we found out how much it equaled. Now they give us the equals, and we find out how much x is. All right, so let's go ahead and do this. So we have 5x minus 3 equals 2. So again, we want to do the opposite of our order of operations. So I start off with any addition, subtraction. All right, well, I have plus 3. And again, we have to do it to both sides. All right, so let's just go put a big star here, and just a reminder, both sides. You've got to be fair. You can't give one side 3 extra cookies, but not the other side. Alright, so 5x, negative 3 and positive 3. What's negative 3 and positive 3 give us? Negative 3 and positive 3.
0.
0, right? They cancel each other out, which is why we did that, because we wanted to get rid of it. So that's just 0. I like to just put a line through it. You don't have to write 0. And then what's 2 plus 3? 5. Okay. So now we have, again, this is multiplication. And what's the inverse operation of multiplication? Division. So divide both sides by 5. Alan, are you with us, my dear? Thank you. Keep that head up. What is 5 divided by 5? 5 divided by 5. 1. So this is just saying 1x. Again, I like to put the line through it. It's not 0x, it's 1x. But I don't need to write the 1 in front. I can just put x. What's 5 divided by 5? 1. And so again, we can see that we solved x equals 1 is what makes this true. So before they gave us that, we found out what it equals. Now they give us what it equals, we find out what x is. Questions with that? Alright, so let's go and flip the page over. Alright. So again, our goal is to isolate the variable. Isolate the variable. Isolate the variable. Isolate means get it alone. Solamente. Variable, that's our letters, right? You might have, I'm going to skip letters. What is that in Spanish? Letras? Is that right? Letters? It's not letras. Is that right? No? Letras? Letters? Letras? Yeah. Okay. Alright, so whatever we do to one side, we must do it to the other side. Good. Must do to the other side. That's what we're just saying. And we undo operations by using their inverse. Again, that's think of it as opposite. Okay.
Wait.
Oh, I'm sorry. I just got so excited to solve some equations. Ah! There. So what we're doing today is just 1 and 2 step equations. What it means is it's only going to take 1 or 2 steps in order to solve.
Okay.
Next class we'll have more than just 2 steps. Okay. Now if you'd like to draw that line down the equal sign, you're more than welcome to. What's important is that you write what you're doing on both sides. Are you with us? Are you with us? Alright, so our first one. What do we have to do first? Go ahead, Emma. Yeah, we want to subtract 10 from both sides. So here's a good question is, do we do anything with the 10 or do something with the 8, the negative 8? So what you want to look at is what's kind of connected to your x, okay? So since the 10 is connected to my x, that's what I want to get rid of. If I add 8 to both sides, you're not doing it wrong, you're just taking longer to get there. Because then you have to subtract 18. So you could do that, it's just going to take longer to get there. So again, we want to subtract 10 from both sides, and this is what I expect to see when you are solving these, is to write out which step you're doing. And I'm just going to draw on the line since it helps out some of us. Alright, so we have x on the left, and then we have negative 8 minus 10. What does negative 8 minus 10 give us? Negative 18, good. On the back side. So it's x equals negative 8. I'm going to erase my line a little bit so we can see it. Equals it. Okay. That's right. Let's take a look at number 2. At a minus 2 equals 9. Again, I need to get rid of what's with the a. So it's the opposite of minus 2. I'll give it plus 2. Okay. So plus 2. Then I'm going to do it to both sides. Whoops. Alright, I just made a big mistake. I wrote x. Do we have an x in here?
No.
No. So if you were to write x like that, I'd say, where did x come from? I'm not doing anything with x. So make sure you do keep that same variable. Alright, so a equals 9 plus 2 is 11. Not too bad, right? Alright, so I'm going to start calling on some of you to specifically help me out with each of these. This means I get to practice names. This is good. Alright, Angela, I'm going to pick you first. Angela. So for number 3, we have 3 times z. What's going to be the opposite that I need to do? Good. Divide by 3. Very good. So I have z. All right, what's negative 21 divided by 3? Negative 7. Good. Ooh, 4 is kind of tricky here. Does anyone want to volunteer to help out with number 4? Okay, I'll help you out, guys. I'll help you guys out. So I have y divided by negative 6. Joanna?
Would you divide 3 by 3?
Ooh, I like your thinking there because we would want to do it to both sides. But remember, we want to do the opposite. So if we're dividing by negative 6, multiply by negative 6. Very good. So we want to multiply by negative 6. I'm going to use parentheses just to help me out here. And I'm going to do parentheses over here. So we want to multiply by negative 6, right? This fraction means we're dividing by negative 6. So we want to multiply by negative 6. And so here, what's happening, we know this is going to cancel. But what's happening is we have negative 6 divided by negative 6, which gives us 1y. What is 3 times negative 6? Negative 18. Okay. 5, it looks like we're almost done, right? All we've got is negative b equals 11, but we have to have the letter all by itself. So we have 11 equals negative b. I need to get rid of that negative. So you want to be careful with this. It's not that we're saying subtracting b.
Plus b.
It's saying negative 1 times b, right? It's saying negative 1 times b. So this one you have a couple of options of what to do with it. But we'll just stick with probably the easiest one. That's not a negative 16. That looks like negative 16. I'm going to rewrite this out. The same thing as negative 1b. Negative 1 times b. Because when we have just one variable, we don't put the 1 in front, right? We know that that means it's just 1. So what is the, again, we're multiplying. What's the opposite of multiplying? Divide. So we want to divide by negative 1. And when we divide, what's 11 divided by negative 1? Negative 11. All it does is just change the sign. So I have negative 11 equals b. Now, if you stopped right here, I wouldn't be completely satisfied with your answer. What's the difference between what we have here and what we have for all of our other ones? What do you guys know is different about them? Yeah, our variable needs to be on the left. So just make sure that you flip it around in the end, b equals negative 11. That's important because when we go to do our inequalities, we have to have that letter on the left side. All right. Number 6. Let's see, who can I call on for this one? Andrew, I'm calling you. For number 6, so we have negative 4 plus c. So what's going to be the opposite of minus 4?
Plus 4.
Plus 4. Good. So we're going to go plus 4, plus 4. 5 plus 4 is 9. Negative 4 plus 4 is just 0. See? And again, let's just flip that around. Okay. All right, questions so far? Okay. So now for number 7, this one's a little trickier. Does anyone know what to do with number 7? We have 4/5 times x. Emily, you want to give it a try?
Would you want to make it so whatever 5 go into number 4, would you multiply it or something?
Yes.
8 times. Wouldn't it be 50%?
So you can kind of think through it that way, like you're kind of guessing and checking with that. But I'm going to take what you said and we're going to steer it in a slightly different direction. So we have 4 divided by 5 times x. Or in other words, can we read this as 4? You guys saw me oriented, right? I'm not going crazy. 4/5 times x. So I'm doing 4/5 times x. What's the opposite of multiplying? Dividing. So we would want to divide by 4/5. But look at how complicated this looks. Then we've got 8 divided by a fraction. That's pretty complicated. Does anyone remember what we can do instead of dividing by a fraction? What we can do instead? Joanna?
Multiply.
Multiply. We have to do something with it. We don't just multiply by 4/5. Good. Multiply by the inverse. So what that means is we just multiply and flip. So we want to, instead of having 4/5, we would want to multiply by 5/4. And we're going to do that to this side as well. 5/4. Okay? What we have, if you were to type in your calculator 4/5 times 5/4, it gives you just what? What we have is 4 times 5 is 20, 5 times 4 is 20, 20 divided by 20 is just 1. So I have on the right side here x. Now again, you can put this in your calculator. 5/4 times 8. Just make sure you put parentheses around it. I'm going to go and pull up the calculator here. It'll let me bring it up. So just a reminder of where that fraction bar is on your calculator. So again, I can put it in as parentheses, 5 divided by 4, parentheses, times 8. And we get 10. Now, if you have a nice updated calculator like we have here in class, then you can go ahead and use the nice fraction bar. Does anyone remember how to get that nice vertical fraction?
The math.
I'm going to go with alpha y equals. Just hit enter. That gets you that nice fraction bar. So I can do 5 over 4. Make sure you get out of your fraction by arrowing to the right. And then I do times 8. Okay, so either way, you'll get the same answer. Sometimes that vertical fraction bar is a little bit nicer to work with, because you have to have those parentheses when you're dealing with those fractions if you don't use the vertical bar. All right, so we get the same answer either way. We get x equals 10. And again, we want to flip that around to be x equals 10. All right. So now if we take a look at number 8, we don't have just one number we have to get rid of. We have two different things. We have a 30 and we have a negative 5. So you want to think the opposite of gem dots. You want to go inverse. All right, so we're going this direction. So we want to start off by getting rid of any addition subtractions. So let's see. Oh, wait, who said that? Where did that come from? Alan, thank you. Alan said we want to add 5 to both sides. Good. So we still have 30x. Negative 5 plus 5. Is that okay to have a 0 there?
No.
It's okay. 0 is sometimes one of our solutions. Whoa, I forgot my 30 though, didn't I? It's not okay to change 30 to 3 magically. But it's okay if we get 0, that might happen. Is it going to happen often? Well, probably not, but it's okay if it does happen. Okay, so I have 30 times x. Sanjeev, if I have 30 times x, what do I want to do? The opposite of multiply. Good. So we want to divide by 30. All right. Ooh, see if you can figure this out without your calculator. What's 0 divided by 30? 0. If I have 0 cookies to give to 30 people, each person gets 0 cookies. You had nothing to give them in the first place. You shouldn't have told them you were bringing cookies. All right, x equals 0. And you can always check your answer. Take 0 and put it back in. 30 times 0, 0 minus 5 gives me 5. Okay. Number 9, again, we have a couple of steps here. Alright, so I want to go ahead and add 1 to the sides. So I have 2x equals 8. Alright, and then again, the opposite of multiplying would be dividing. So I have x equals 4. Okay, questions so far? Take a look at number 10. Uh-oh, there's a fraction in there. Don't let that freak you out. I'm going to take it one step at a time. What's going to be the first thing I do for this? Anyone want to volunteer? What's going to be the first thing I do? Sam? Subtract 6. Good, subtract 6. So I have 1/3 x equals negative 14. So negative 8 minus 6, those are both negatives, gives us negative 14. Okay, so now I have to get rid of my 1/3 x. Okay, so again, to get rid of that fraction, we're going to multiply, and the reciprocal is what we call it when we flip it. 3 over 1. What is 3 over 1? 3. Just 3. So you can multiply by 3 or say 3 over 1, you'll get the same answer. Alright, so over here, just have x. And then again, the same thing, just multiply by 3. So negative 14 times 3. Or you can put your calculator through 1. I'll let you guys know. I think that sounds right to me. Can I get a confirmation it's negative 42?
Yeah.
Very good. Now, so far we've been getting nice whole numbers for our answers. Is it possible to get a fraction for an answer? Yes. Is it possible to get decimals for answers? Yes. We do have decimals and fractions. We're in high school. We don't always have nice whole numbers, okay? A lot of times we'll have nice whole numbers, but not. Okay. 11. What's our first step? Anybody?
Negative 3.
Yeah, good. Subtract 3. And 4x equals 8. Alright, we have 4 times x.
We do divide.
Good. Divide by 4. 8 divided by 4. 2. Awesome. Okay, 12, they're trying to be sneaky here. We have negative 5 plus 9x equals 13.
We did,
Yeah, we want to get rid of this negative 5 first, because the 9 is being multiplied, right? We want to get rid of our negative 5.
positive.
Good, so we want to add 5 to those sides. 9x is 18. Now we get rid of that 9. Divide by 9. X equals 2. Very good. Okay, not too bad, right? Hopefully this was familiar. Did it last year. So now let's take a look at our inequalities. Alright, so now for inequalities, it's going to be the exact same process, just be mindful of one more thing. So inequalities, a reminder that inequalities is where we have the less than, greater than, less than or equal to, greater than or equal to. These are inequalities. They're not equal. There's a range of the answers for it. Alright, so solving inequalities is floating above the line. Try guessing where it's going to write. Solving inequalities follows the same steps with one more rule. So it's the same thing, just we have to watch out for one more thing. If you multiply or divide, remember they were inverse operations. So if you multiply or divide by a negative number, then does anyone know what we have to do with our inequalities rule? Yeah, we have to flip the sign. You must switch your inequality symbol or flip your inequality symbol. Alright, flip, and I'm going to put in parentheses, switch. So if you had this starting off, you would have to switch it around that way. If you had this starting off, you have to switch it around that way. That's only when you multiply or divide by a negative, not just subtract. We're not doing that for subtract. Just multiply or divide. Okay, so let's take a look at number 1. Again, same process, just if you multiply or divide by a negative, it's flip the sign. You with this, Anthony?
Yeah.
Okay, let's go ahead and turn so our knees are underneath their desks so we're facing forward. Alright, what's our first step for number 1? Good, we want to subtract 5. So negative x is greater than or equal to 3 minus 5, negative 2. Okay, again, make sure your variable is always on the left side. Alright, so I have negative 1 times x, so to undo it, we're going to divide by negative 1. And this would be that example where we're dividing or multiplying by negative. So I have x. We have to flip the sign. Negative 2 divided by negative 1. Questions with what we did for number 1? All right. So for number 2, again, we're going to do the same process, add and subtract first. Okay, 2y is less than, what's 7 plus 5? 12. Okay, so 2y is less than 12. Divide by 2, very good, everybody. If y less than 12 divided by 2, so 6. Did I need to switch my sign for this one? No. It wasn't a negative 2, so we're going to leave that alone. Yeah. So now what this is telling us is that there's more than just one answer of what will make this equation true. So let's actually look over here for our y. I start off with 2y minus 5 is less than 7. There are technically infinite answers that will make this true. Anything less than 6. Do we include 6 as one of our answers? No, it says less than. It doesn't say equal to, just less than. So 5 would work. 2 times 5 is 10, minus 5 is 5. Hey, 5 is less than 7. Anything less than 6 will make this inequality true. So because there is more than one solution, we will present our answers both written with this inequality, but also on what we call a number line, graphing it on a number line. You guys have dealt with number lines before, but you perhaps have not graphed. So we have a number line where we often put 0 in the middle, and then 1, 2, -1, -2. That's the number line. So what we're going to do is we're going to represent our solutions on the number line. Now, if it would have just been x equals 2, we would have just put a single closed dot on 2. That's our only solution. But it says x is less than or equal to 2. So it's not just this, it's everything less than that. So everything less would be all of these numbers over here. And so that's what we're going to be drawing to represent, hey, anything over here is a solution. So that's the further step that we're going to be taking. So let's talk about how we graph our inequalities on this line. So the first thing to do is to solve your inequality, right? We've got to know what our answer even is. So solve your inequality. Solve the inequality. Make sure, next step is make sure your variable is on the left, which we've already talked about when you do that. Make sure its variable is on the left. It's on the left. I always get my left and right mixed up in Spanish. Is it a la derecha's left? Or is it izquierda?
Yeah.
Is it izquierda? Yeah, I always get it wrong. Okay, a la izquierda. Okay, so that's basically having it in this format, right? Y is less than 6. My variable's on the left, and we've solved it. Okay, so next, we have to number the number line. Number the number line. Now, when you're numbering your number line, make sure you're consistent. So we want to number it with the scale. Notice here I went by ones. I shouldn't go by ones on one side and then by twos on the other. So make sure it's consistent. All right. And then once we've got our number line, we just have to decide two things. First of all, is my dot open or closed? And then which direction are we going in? So our next thing is the dot. Is the dot open or closed? Open.
Is that a D?
Yes, that's a D then. Is the dot open or closed? And we'll talk about in just a moment how we know which one to do. And then we have to decide which way our arrow goes. As long as you have your variable on the left, your arrow just goes in the same direction as your inequality. Notice here y is less than 6. That means my arrow is going to go to the left. That's why it's really important we have our variable on the left side. So that's our last thing, is to draw your arrow. Draw your arrow in the same direction as your inequality. Same direction. That's the inequality. So really what we have to do is, after we've solved it, just label our number line and put the dot in there. Okay, so we talked about what's the difference between closed dot and open dot. We already talked about how closed dot means that equals that. So anything that has the or equal to in it is going to be a closed dot. So closed dot is going to be equals, less than or equal to, greater than or equal to. Now, our open dot means we don't include it, so it does not equal that. So our open dot means either just less than or greater than. It's not part of our solution. Like above, we had y is less than 6. We don't include 6. Anything under it, 5.9999999, that works, but 6 doesn't work. All right. Arrow to the left are the inequalities that point to the left. So we have less than, or equal to. Notice they're both going to the left. This means our arrow will be to the left. And then likewise, arrow to the right. Anything that's pointing to the right. So greater than or equal to. Notice it's pointing to the right. We draw it. All right, so we're just going to do a couple examples here. Again, solving is the exact same thing. Just once we have our answer, then we're going to also put that on the number line. All right, so number 1 here, and it tells us to graph. That's what indicates we'll be doing the number line. Notice here the number line was drawn for you, but it's not labeled. We have to do the label. All right. So let's go ahead. We have a positive 9. How do I get rid of that positive 9?
Minus 9.
Good. Subtract 9 from both sides. So 4x is greater than, what's 21 minus 9? 12. 12. Good. 12. So 4x is greater than 12. And we read that as 4 times x. What's the opposite of multiplying? Dividing. So instead of 4 times x, we want to divide by 4. Again, on both sides. So I'm left with just x. Do I flip my sign? No, I didn't multiply by negative or divide by negative, so we keep it the same. 12 divided by 4 is 2. All right, so let's double check. We solved. Is my variable on the left? Perfect. I'm going to put a box around that. I like that answer. So it says x is greater than 3. Now, when we draw our number lines, you don't always have to have 0 in the middle. Because like what if it said x is greater than 12? Then you have to put 0 and draw 12 little dashes. What do I mean by that? Oh, so we have, I want my x to be on the left side, we don't want it to be over on the right side. So when we are labeling our number lines, you don't have to always have 0 in the middle, okay? So, because if we had x is greater than 12, then we have to draw 12 little tally marks. So just pick a couple numbers before it. Since 3 is 3 plus 0, I'm just going to put 0 right here. So I'm going to label this one 0. Then I have 1, 2, 3, 4, 5, and this would be negative 1. Okay, so 0 doesn't have to be in the middle. You can move it so it's a little bit easier for you. I don't have 0 in there at all. All right.
It's an open circle.
It's an open circle. Good. You read my mind. Open circle. So above 3, I'm going to draw an open circle. And then looking at my arrow, is it pointing a la izquierda or a la derecha? Right. Good. Did I do my directions correct in Spanish? Yeah. Okay. I should never give directions in Spanish because I'll just set them to the wrong location. And there we go. So I have my box answer and I have my number line answer. Questions with that? It's not even or odd if it has the equal to. So if we have the equal to, that's a closed dot. If there's no equal to, it's an open dot. What this means, when I read this as a math teacher, I look at this and say, oh, this is open, so we don't include 3. Everything above 3, so like 3.001, we include that, but not 3. All right, so let's take a look at example 2.
Plus 4.
Very good, I saw 2. Plus 4.
Then you put the 8x. I mean, negative 2x.
Good, negative 2x greater than or equal to 18 plus 4. 22. Good. All right, so negative 2 times x. The opposite would be divide by negative 2. Good. And right now, you should have this little alarm going off in your head. It's like, woo, woo, woo. We divided by a negative.
The sign flips.
Flip the sign. Good. Turn that sucker around. X is now less than or equal to 21. 22 divided by negative 2. Negative 11. All right, our x is on the left. It's all by itself, so we've got our answer here. I'm going to put a box around that. Okay, so just again, here we've got negative 11. So I don't want to put 0 on here because I'm going to be drawing for forever. So let's just go a little bit to the left and to the right. So I'm just going to go and put negative 11 right in the middle. So that might be an easier way to think about how to label your number line. Is your answer, just put that in the middle. And then you'll label to the left and to the right. So if I'm going to the left, I would have negative 12, negative 13, negative 14. What do I have here? Negative 10, negative 9, negative 8. We didn't even hit the negative numbers here. Alright. So that might be just a good way to think of it. Whatever your number is, just put that in the middle and then go some to the left and to the right. Okay, is this open or closed?
Closed.
Closed. We include it. It is equal, so we put a closed dot above it. And it's to the left. It's pointing to the left. There we go. That's it. Questions with that? All right. So what we're going to do for practice now is a round the room activity. So this activity has this. It says it's number 2 on your worksheet. So this is similar to what we did last time. You'll see pink pieces of paper around the room. And we have problems, I think it's 1 through 16 again. So you'll come up, you'll solve it, do your work on here, and then put your answer. And then we'll go over them. Again, you don't need to go in order. You can just kind of move around the room. Well, ideally, at a relatively reasonable pace, we should just be sitting next to the same person. So yes, move around at your own pace.
Did you grade our packet?
The homework packet, I haven't graded it yet. I've got about 150 tests to grade right now, so I'm slowly working through a lot. But I will get those back to you once I have them graded. Let me write you a task form. Just know let me pass this out first. So you guys finally get your agenda so we can start writing post-it. Oh. I'm so excited to see my post-it. All right, is there anyone that did not get the worksheet?
I don't.
What are you talking about? All right, and I'm gonna go ahead and pair you guys up and put you around the room. So hold on just a moment. I love that anticipation there, Alan. Okay, so taking a look at our around the room activity we were just doing. There are a few that I want to take some time to go over because I had quite a few questions on these. So the first one was problem number 2. So you guys did a really good job. You added 1 to the side. You want me to write? Okay, I'll just write it on the smart one. 4, 9, 6. Oh, that's okay, so you guys did really good. You added 1. 4/9 x equals negative 20. Some of us are still struggling when we're dealing with adding, subtracting, positive, negative numbers, so you just double check that on your calculator. Alright, so then this is the question I got a lot. Is what do we do now? So we want to multiply by our reciprocal. And that's reciprocal is a fancy way in math saying flip the fraction.
Good morning, it's Martha Interruption. Seniors whose last
And
name
when you put this in your calculator, you get negative 45.
need to report to the cafeteria with all ratings for TA meeting with your school counselors, Mrs. Markinson and Ms. Adkins. Thank you.
Okay, so that was just for seniors. Don't have to worry about that. He just got held back. All right, another one that I want to look at is problem number 8. Okay, so problem number 8, if you would go ahead and turn to that. So problem number 8, I have that we have 8 minus 3 halves x. I need to get rid of my 8 first. That's a positive 8. So what's the opposite? Negative 8. Good. So our inverse is negative 8. So I have negative 3 halves x equals 15. Anthony, just turn. So again, we want to do the multiply by that reciprocal. Multiply by 2 over negative 3. And it doesn't matter where you put the negative, you'll get the same answer. So x equals, and that gives us 30 divided by negative 3, which is negative 10. Now, real quick, let's just pretend there wasn't an inequality, but let's pretend there was an inequality here. Since I'm multiplying by the negative, what would I have to do with it? Switch it. Okay, now we didn't have one here, so that's okay. So it's just a reminder for a couple of those. I'm going to go ahead and pass out your homework. If you would go ahead and turn off your calculators, put the cover back on, return to the boxes that you got up front, and erase your name from the board. I'll pass out homework while you're talking.
Thank you, Miss.
All right, so homework is coming out. Your homework is Unit 2, number 3, worksheet number 3. I think we might need one more in that row. Omar, come back. Is there anyone that did not get their homework worksheet number 3? Okay. And again, make sure you turn your calculators back and erase your name from the board. Now, when the bell rings, you want to go to TA, and then after TA is senior 8. So TA, senior 8. Just a reminder, those of you that did not get your homework done for today, make sure you get that done for next class as well. We still have a couple minutes till the bell rings, so just stay put in your seats until that bell rings, but you're welcome to use your phones for these last couple minutes.